Good evening to everyone.
Good evening, sir.
Okay, so tomorrow onwards I will be taking the class from 6:30 evening because Balbir sir will be not taking, so I will take from 6:30. Mean my class. I will be taking my oral class. Okay, let's start from the AC plant today. AC and refrigeration. We'll try to see this one and try to complete it today. Here is a diagram of the flow diagram, you can say, or P and I diagram, generally it is known as, not as a flow diagram, but P and I. So let's see how it is going to work. Before going this one, I hope everybody know about this pressure enthalpy or temperature entropy diagram, because that is important to understand that one. So little bit we will talk about this. Now basically any refrigeration plant which is going to work, it is going to do basically 4 process. Okay. AC or refrigeration systems that does 4 process. So what is this 4 process? First is known as a compressor. Compression. That means whatever that is vapor is coming to the compressor, that is the low pressure side or suction side. So that is known as a suction. This suction is a low pressure. It is going to be low pressure. And that's why sometimes we say this one is a LP line or suction line. Okay, so this is LP line. So this low pressure, what is low pressure basically? What is coming to the suction? So LP line is supposed to have only the vapor. It is supposed to have only the vapor. That is what we say in the general language, gas. Okay, gas. So only the vapor that's supposed to be coming to the suction line. Now, when it is going to be compressed by the compressor, when it is going to be compressed by compressor, so the compressor which is going to compress this one. So after this one, after the compression, it is going to rise the pressure. So compressor which is going to compress this one, Then there is going to be the discharge line. Discharge line. So this discharge line is known as a high pressure line also, or HP line, high pressure line. So this is also known as a HP line. When we say HP line, this is a same vapor, but now this vapor after the compression, the temperature and the pressure both are increased. Okay, so it is going to have the high pressure HP as well as it is going to have the high temperature HT. Remember, this is going to be the high pressure, high temperature. When it is entering to this one, this low pressure, so this low pressure is a LP and it is also LT. Okay, low temperature and low pressure. It is going to be low pressure, low temperature. We'll talk about this low pressure, low temperature, high pressure, high temperature also. So after this one, there is going to be the condensation. Condensation. This is the second process. Second process is condensation. Now, in this one, this process, this condensation, basically we are going to remove the lateral heat. Lateral heat is removed. Now, when we are talking about the lateral heat which is removed, it doesn't mean that vapor which is there. So vapor is still going to be high pressure and high temperature. It is going to be only the heat is removed. Now, what is the lateral heat? Lateral heat, the meaning of this one, that vapor, okay, vapor, first of all, I must write here, condensation. So, we are going to condense the vapor. I will write vapor here. And this vapor is of high pressure, high temperature, which will change into the liquid of the high pressure and high temperature. So what does the lateral heat is doing? Lateral heat, it is changing the vapor into liquid, and this is known as a condensation. What about the pressure and temperature? That is going to remain same. Okay, there will be no change in that one. It is going to remain same. Only it is removing the heat, so it will change from vapor to the liquid. It will change from vapor to the liquid. Okay. Now, third one, it is going to do that is the work that is known as a expansion. Expansion. Expansion means to expand. To expand. What we are expanding? We are expanding the volume. Okay. So expand means we are going to expand the volume. How the volume is going to be expanded? So volume which is going to be expanded, that means the dia. Now here, the expansion means we are going to expand. So because this liquid is going to have a high pressure liquid, and when we are going to expand this one, so it is going to the low pressure side. Means expansion, if this is also known as a thermostatic expansion valve, we'll come to that one. So this thermostatic expansion valve is there. Okay. Like this. And this is the nozzle. What happens here? We are going to have a liquid. So this is a liquid. So this is the high pressure high temperature liquid. Refrigerant liquid. Liquid means refrigerant liquid. Now, when it is going to come out from this, it will get atomized. Okay, it is going to change into the tiny droplets. Okay, so it is going to atomize. So it is a very tiny droplet. So it is going to be a mixed of vapor and liquid. That is the one thing when it is going to come. Second, the volume is going to increase. Volume increases. How the volume is going to increase? Just see here the dia. This, suppose this is the dia. Okay, I'll just make with another color. So this is a dia. Generally, the dia of this TV before that, suppose it is the D. Then the dia after the expansion valve, okay, the dia is going to be 2D. It is going to be 2D, level of the D. So the area has increased. Once it is going to increase, it is going to expand. So volume increases, so it is the whatever the mix of vapor and liquid are there, it is going to expand. Expand. Now, when it is going to expand, what will happen? Both the things is going to happen. That it is going to lower the pressure LP. It is going to be low pressure. And the temperature also it is going to decrease. So it is going to be LT and LP. Both will be there during the expansion. LP and LT. Temperature also drops and the pressure is also going to drop due to the expansion. So this is known as the expansion. Okay. Now, fourth one, that is known as a evaporation. Now, evaporation means evaporate. What we are going to evaporate now, whatever this LP pressure is there, this is a mixture of vapor and liquid. Because it is having the low pressure here and low temperature, due to that, when it is going to pass through the evaporator, okay, it is going to boil off. This vapor and liquid especially, because this is a tiny droplets of the vapor, it is going to boil off. Why it is going to boil off? Because it is going to take the latent heat. Now again the latent heat has come, latent heat. So it is going to take the latent heat, lateral, I have written that is latent heat, okay? That is the latent heat. So this latent heat, it is going to take. Whose latent heat? This latent heat is there of the air. Here, because we are going to have a fan, so this fan is going to blow the air. It is blowing the air, and this air, the latent heat of that one will be taken by the this vapor and liquid. Means it is going to take this and it is going to boil up. So what happens when it is going to pass through the evaporator and latent heat taken by the vapor, this air is going to be cooled down. It is cooled down. Okay, it is going to cool down. And this is how it is going to cool down, and this will boil off because it is a low pressure. So this boiling point is decreased. Boiling point is decreased. Boiling point is decreased. Now, when the boiling point is decreased, it is going to boil off in the low pressure. Okay. Now, When it is going to come out from the evaporator, it is going to change into the vapor, and this vapor is known as a 100% vapor. 100% vapor. This 100% vapor is the other name is also known as a saturated vapor. Now the word which has come, saturated vapor, we'll talk about this. Okay, so it is going to be saturated vapor. Again, it will go to the compressor, which is going to compress. Okay, then again, there is going to be the same way it is going to repeat. So this is the cycle that will follow. So what we have seen is this is the basic one. The fourth process you can see here, this is what I was telling you. This is the fourth process we are doing here. Okay, so this fourth process is basically compression by the compressor, then there is a condensation, then expansion, and thereafter the evaporation. Okay, compression, condensation, expansion, and the evaporation. Compression, here it is going to be PC. Remember this PC. QC is the latent heat. This is a latent heat. And this is the PC. Again, it is going to be the PO. QO is again the here latent heat. It is talking about the latent heat. And again, this is the PO and it is going to the compression. Now, when we see about the temperature, here also it is going to come along with the TC, it will be the PC and TC. Here also it is going to come TC, then there is going to be the TO, and here also it is going to be the TO. What I have written, you will see in the next graph. Okay, you can take a screenshot of this. There is something known as a temperature entropy and the pressure enthalpy diagram. No, this is not like I am going to teach you this, just I am going to tell you to understand this one because it is going to help you to understand many things. And that's why I am teaching this one. Now, when we see the temperature entropy and pressure enthalpy diagram, there is a critical point in this one. This is known as a critical point here. Okay, the top one, that is the critical point, CP. The critical point, CP. This side from the CP to x0, can you see here x is equal to 0? Here also x is equal to 0. This is known as a saturated liquid line. Saturated liquid line. This is the saturated liquid line. Same you see here also it is same. Okay. Then we see here something, this one. This is known as a saturated vapor line. And this saturated vapor line is here also, it is same. Okay, so both graph is having the same. Okay, this is a saturated liquid line and this is a saturated vapor line. Now, in between of this one, in between means when I am talking about in between means this part. This is the part. Okay, this is the part. What is this one? Or here also same way, similar way. Okay, what is this? This part, this is the shaded one. So this part is known as a mix of vapor plus liquid. This goes same here for this one. It is same, mixed of vapor and liquid. This is the part. because this side here it is saturated liquid means 100% liquid this side. Once it is going to come, it will come to the 100% liquid. And when it is going to come to this line, this side it's 100% vapor. Okay, so you need to understand this one. That means when we say saturated vapor, it is 100% vapor, there will be no liquid. When we say saturated liquid, that means 100% liquid, there is not going to be any vapor. Okay. So this is about the saturated line, liquid line and saturated vapor line. Okay. Now we are going to talk about compressions, all these four process. Now if you see this process, okay, what we are talking about from 1 to 2, this is a compression mode. Okay, this is a compression. This is a compression. Okay, similar here also, it is same. It is a compression. And that is what it is shown here. Sorry, 1 to 2. This is the inlet and this is the outlet. 1 and 2, this is a compression. Now, what it is compressing, you can see the inlet of the compression is 100% saturated vapor. This is a 100% saturated vapor, or we'll say saturated vapor. Saturated vapor. Now, in this case, the pressure is also low and temperature is also low. That will be same goes to this point. This point is same. Okay, saturated vapor. So this is going to be same 1, 2, 2. After the compression, what happens? The temperature is going to rise and pressure is also going to rise. So this is going to be HP. And in this one, we see this is going to be the HT. So this 1 and 2 is a compression. So it is going to be high pressure and here it is going to be high temperature. Temperature little bit it is going to reduce, but still it is going to be the high temperature. So from 2 to 3 or from here also, when it is going to enter to the condensation, okay, so we'll say 2 prime here. Here also I am going to write just 2 prime. So from 2 prime to 3 or here also 2 prime to 3, this is known as a condensation. Condensation. So this process will start. Here also it is condensation. What is you need to notice here that your pressure is not going to decrease, neither your temperature is decreasing. It is the same line. Here also you can see the temperature is constant. It is not decreasing. Here also from 2 prime to 3, the pressure is not decreasing. It is same. Means during the condensation, the vapor is going to change. So we'll say here this is the 2 prime from here and this is the 3 which is coming out from the condensation, that is going to be liquid. So in this case, the latent heat that is being removed. So during the condensation, the latent heat is removed. Who is removing? By cooling water. By cooling water. So cooling water is going to take the latent heat. So it is going to change the status from the vapor to the liquid. When it is going to reach to the point 3 here, it is going to be 100% saturated liquid. Saturated liquid. Okay. So after the condensation, when it is going to reach, it is going to be a 100% saturated liquid. Now, from 3 to 4, this was the condensation. Here I have written. Now this part, this is known as a expansion. Expansion. This is the expansion. Expansion, it is going to expand. So volume is going to be increased. Although the flow is going to be very less, but volume increases, expand. Okay, and when it is going to reach from 3 to 4, so this point at the 4, it is going to have a mix of vapor and liquid. Because this area, when I started this one, you know it, this is the area, it is going to be mix of the vapor and liquid. Vapor, mix of vapor plus liquid. Similarly here also, so from here when it was saturated liquid, 100% liquid, but when it is going to expand, this is here, this is known as a mix of yeah, mix of vapor plus liquid. Now, as the from 4 to 1, that is known as a evaporation. Evaporation. Evaporation means it is going to evaporate. This also saved from here to here. This is the evaporation. So as the evaporation is going to take place, all the vapors are going, all the liquids that are going to change into the vapor, and it will become, when it is going to reach to the one, it is going to be a saturated vapor. Okay. Now, when it was expansion, you can see the temperature has decreased. Here also, the pressure has decreased. It has come to this level. This is the level that pressure has come, and this is the level the temperature has come. Now you do remember this one, that the temperature here, the temperature of refrigerant and the pressure both are directly proportional to each other. Remember this, the temperature and the pressure are directly proportional to each other. If you want to see the chart of this one, chart of temperature and pressure, whatever the refrigerant you are going to use, generally on board ships, what we use. Now I think we are going to use, this one was R143, but this has been discontinued now. If some strips are there, it's okay. Otherwise, nowadays, what we use, that is the R4, not 4 alpha. Okay, this is what we use nowadays. So all the gases, as per the different gases, they are going to have their own temperature and pressure charts of the refrigerant I'm talking. So whatever the pressure it is showing in the pressure gauge, you can calculate the temperature of that. Or if you know the temperature of the refrigerant, then you can calculate the pressure also, because both are directly proportional to each other. In this graph also you can see, this is the temperature entropy and pressure enthalpy diagram. Both are almost same. It is, you can see in proportion everything is happening. Here the temperature is decreasing, here the pressure is decreasing. Pressure temperature remain constant, here also pressure temperature remain constant. After this again it is going high pressure, here it is going high temperature. Again in this it is going to be constant, no change. Again from here to here it is changing. Okay. So this chart of the temperature and pressure as per the gas, you can calculate. If you know any one of them, second one you can calculate from the chart. Okay. Now, why it was important to tell you, so you can understand. If I say saturated liquid, saturated vapor, mix of the vapor and liquid, now you understand. That is my main motto to tell you about this one. Okay. Now, let's come here and try to understand this one. This is the diagram, and for the exam purpose of view, we are going to see each and everything. There is any question that is asked by the surveyor, try to ask me so everybody know what is the question they are asking. Okay, and we'll try to understand how this works. I will teach you on the view of the electrical, okay, electrical system, what all cutouts are there, how they are working and all. Okay, I am going to touch like temperature and pressure, or when it is going to change from the liquid to the vapor. That I will be telling you. That is the what is the flow diagram it is. But I will be teaching you all the things in the view of the electrical. Okay. Now let's start. Now here, as I have told you that the compressor, this is a suction line, suction line. So this is a suction line, and this suction line is going to be, this is the suction line. From the suction valve, it will come here. So this suction line is a LP line, LP line, low pressure line. Okay, so this also we say it suction line. Now, as I have told you, suction line or LP line has to be saturated vapor. Means when it is entering to the compressor, it has to be a saturated vapor. If there is a big plant, then we are going to have the liquid separator. If it is a small plant, there will be no liquid separator. Liquid separator is there only for the big plants. If big plants are there, AC plant, you will find the liquid separator. Whereas if the small plants are there, you will never find this suction pressure. Oh, sorry, this liquid separator. Okay. Now from here, it goes to the suction pressure or LP switch. What it is known as a LP switch. LP switch. This LP switch, which is going to make the compressor on and off. Compressor on and compressor is going to be off. Now, why this switch is given? This switch is given for the controlling the compressor and also protecting the compressor. How it is going to protect? So when the LP, that is the low pressure, when it is going to be somewhat like 4.5 bar, suppose I am taking here 4.5 bar, compressor is going to be on. But when it is going to come to the 2.5 bar, your LP comes to the 2.5 bar, it will be off. So it will protect the compressor to work like a vacuum, okay, vacuum pump. So that's why it has to cut out this one at the low pressure. Remember this one, this is the LP. LP, that is the pressure, and 4.5 bar compressor will be on and 2.5 bar it will be on. Whatever the data I am giving, this is just this will differ as per the model to model. Here, whatever I am writing, just to make you understand how it works. Okay. Hope you understood this one. Now, this is the LP switch. So it is a simple switch. It is going to have the pressure. One line of the pressure is given to the switch, and the switch is going to work on this one, 4.5 bar to 2.5 bar. How this LP switch looks like, I hope if you have seen, it's okay. If you have not seen, I am going to show you that one. Okay. This is a pressure switch. This is a pressure switch. You can see. And this is also known as a differential pressure switch. Differential pressure switch. Remember this one? Okay. Or this is a pressure switch or differential pressure setting is panel. I will tell you about this one. So pressure switch. Now what happens in this one when we are going to set the pressure? So here we are going to have two knobs. One knob is on here already, it is on here. Okay, this is the knob, and second knob is this one. This is a set pressure. Set pressure. So we are going to have a difference pressure and there is a set pressure. Now as I have written there, you can see 4.5 bar and 2.5 bar. Okay. Now, sometimes you are going to see in this differential pressure switch. This is a differential pressure switch again and again I am saying. So this differential pressure switch, sometimes it is going to have, there are two variants of this one. Okay, one variant that what it says that the cutout is cut in minus differential. Sometimes it will be written like this, cutout is cut in minus differential. Differential. It is like this. Means cutout is equal to, you can say cutout is equal to cut in minus difference. So what is cut in? This cut in is this one. Okay, so that means 4.5 bar. What is the difference we are setting? 2 bar. So this minus 2. So this is going to be 2.5 bar. So this is the cutout pressure and this is the cut-in pressure. That means we are going to have a set pressure here. This set pressure is going to be the 4.5 bar. This will be the 4.5 bar, that is going to be the set pressure. Okay, so we are going to set here 4.5 bar. What is the difference pressure we are going to set? That is the 2 bar. So this is the setting we are going to do here with this one, and this is the setting what we'll be doing here. Now it is going to operate at the 4.5 bar, it will be cutting, and 2.5 bar it will get. Okay, hope it is clear to everyone. So this is the setting of the LP switch. Okay. Now comes to the unloader. So this is the unloader switch. Unloader switch is almost same. It is a direct pressure switch only, unloader switch. In that generally the differential pressure is not there in that case. Okay. Now what is this unloader switch is? So you can see here there is another switch that is given and same suction line or LP that is given to the unloader. So here we are going to have the unloader. This is the unloader. Now let's understand about the unloader. Now there is a difference between this unloader and the MAC unloader. We main air compressor, MAC. MAC is main air compressor. Main air compressor. Do not get confused between this. So there is a unloader in this also. And there is a unloader in this. What is the purpose of this unloader? This purpose of this unloader to run the compressor without load. During starting and before stopping. Okay, that is the purpose of this unloader. Even in between, intermittently also, it goes without load. Without load means when this unloader is energized, when it is on. Okay, when it is off, first we'll see when it is off, then no air goes to the bottle. No air goes to the bottle. That is the air bottle. And when it is going to be on, then air starts filling in bottle. So what happened with this one? This air does not go. No air goes to the bottle, means it drains out. Drains out. So when it is going to drain out, okay, why it drains out? So that any moisture plus oil are removed from line. That is the one purpose. And second purpose, this is the one purpose. Oh, let us B okay. Moisture plus oil are removed from the line. And second, during starting, it should be started without any load. Any load. Otherwise, it may trip on the OCR may get trip. OCR may get trip. OCR may trip. That is the reason why it is starting without load. Okay, due to the inverse current, generally it will get tripped. So this is the two purposes are there. It is going to start without load. Hope it is clear about the math. Okay. Now here the unloader is there. This is very different. Here it is going to control the capacity. Okay, it is going to use for a capacity control. Let's understand what is this capacity control. Okay. What is this capacity control? Now suppose we are going to have a 3-stage or 4-stage we can have. Sometimes we have 4-stage or 3-stage compressor. Okay, suppose this is a 3-stage compressor. We are going to have a piston here. Okay, this is the pistons. Okay, like this. Now these pistons are going to be connected to the crankshaft. Like this, it is connected to the crankshaft. Now suppose this is the stage 1 and this is the stage 2 and this is the stage 3. If I am having a compressor of 30 tons, that means the 30 tons cooling it can do. Now 30 tons, if it is the summer or winter, I do not require to always run on the 30 tons. That means I can do a capacity control. How I can do? If this is going to provide me 10 tons, this is going to provide me 10 tons of cooling, and this is going to provide a 10 tons of cooling. Okay, 10 tons, this is 10 tons, and this is 10 tons. Then, as the temperature is going to increase, so first I will switch on this one, number 1. So number 1 is going to be on this stage. So if it is on, it is going to provide the 10 tons cooling. Now if the temperature is rising, then what will happen? Now second stage, that is also going to be on. That means now in the second stage, okay, let me write little up. So initially, I'll switch on only the stage 1. So it is going to give 10 tons cooling. Now, if the temperature is rising in the accommodation, then I will switch on this both. Okay. So it is going to give a 20 tons cooling. Now we are almost in the summer region. Then further the cooling is required. Then all the three stages are going to be on. So it is going to provide a 30 tons cooling. So this is how we can do a capacity control. What is known as? This is known as a capacity control. That means this unloader is doing a capacity control. Now, how it is going to sense? Then when it has to go for a 20 tons or 30 tons. As I have told you, temperature and pressure both are going to have a proportion. Means temperature and pressure is directly proportional. Okay, in this. Remember this one again. Okay, when the room temperature is going to rise, room temperature is going to rise, same way the LP, low pressure, is also going to rise. That means if I am going to have this unloader, so this unloader, I am going to set it, suppose 5.5 bar. Second setting, I am going to do it 7.5 bar. So 5.5 bar will be switching on the second stage and 7.5 bar will be switching on the third stage. 1 bar, first one is going to be by default when the compressor is on. By default, it will be on always. So there is no unloader for this number, this compressor one. Generally, it is not there. It is directly, it is going to be on. When the compressor is on, first this is going to be on. And rest all are going to have the settings. So that means what is this? 5.5 bar and 7 bar. This is the LP. That means if the temperature is going to increase, LP is also going to increase. So that this unloader is going to be on if the LP is 5.5 bar. If further room temperature increase, it goes 7.5 bar, means third stage is also coming. That means this unloader, which is doing a capacity control, okay, it requires the LP line or LP, that is the suction pressure is required. Okay, hope it is clear to everyone. So why we give the suction pressure to the unloader to control the capacity control. Remember this one, capacity control is always done by the LP, low pressure. Okay, this is the question that I've been asked. Okay, next.
Sir,
Yeah, tell me.
Sorry, again, one time told.
but how it is draining out moisture and oil from the line?
Which one?
Sir, you have mentioned inside the unloader.
No, that I have told for the Mac, not for this. This whatever I have told for the main air compressor. So there is
Okay.
the unloader of the main air compressor and the refrigerant compressor. Okay, that I was saying here. So there is entirely different role of both the unloader. This unloader is different. This unloader doing a different role. That is what I told you here. This is about the Mac. There is no link of this one and this unloader. This unloader does the capacity control. That's it. It is not going to remove anything. Got it? Understood?
Yes, sir.
Yeah, this is a compressor unloader. That is the refrigerant compressor, REF, refrigerant compressor. Whereas this is a main air compressor. So this unloader is totally different, the role of this one. This unloader, the role of this is totally different. Okay. Now, next, there will be the gauge. So, suction pressure gauge or LP gauge that will be there. You can see here LP gauge. Okay, that is given. This LP gauge is generally it is a compound gauge. What is this compound gauge? Just I will tell you about this also. I have a photo. Right. Okay, this is going to be a compound gauge. Here you can see. Now, what is the meaning of the compound gauge? Compound gauge is, if you see in this one, it is going to have the, sorry, the vacuum scale. You can see from here to here. This is a vacuum scale. Okay, this is a vacuum scale. Whereas from here to this side, it is a positive pressure scale. That is this one. Okay, other than this one, this is a positive scale. You are going to have both the gauge in this. It is negative also and the positive also. Second, generally, this LP gauge is always having, generally, you will find a built-in PT chart, pressure temperature chart. If you see clearly here, this is going to show you the pressure, and here inside it is showing you the temperature, and there are the different gases, R22, R12, or something is not visible, that is given. Okay, so accordingly, you are going to have here the temperature of that one. So whatever the pressure, you can see the temperature of that. So it is going to have a built-in PT charts also. Okay. So this temperature also you can see. These all are in the degree Fahrenheit. You can change into the centigrade also. Okay. So this is the built-in chart. So this all information are there. Main thing, compound gauge means it is generally going to have these two information 100%. This is a vacuum scale plus the positive scale. And in some cases, 99% it is going to give a built-in PT charts also. So you can compare that what should be the pressure or what should be the temperature. It is having a correct pressure and temperature or not. Okay, so you will come to know. So this is the built-in PT charts are there in the compound gauge. So this is the one important one. This gauge is there. So this question has been asked. Okay, the type of this gauge. What is the gauge? What is the specialty of this gauge? Suction pressure gauge or LP gauge. Now coming to the differential oil pressure switch. Okay, differential oil pressure switch. Now this differential oil pressure switch is going to have two pressure. One is the LP pressure and one is the gauge pressure. Here, oil gauge pressure you can see. So these two are there. We need to understand this one, how it is working. Okay, let's see about this. What happens? First of all, we should know that oil pump, oil pump, this is situated or located inside the crankcase, inside the crankcase. Okay, crankcase is already having the pressure, that is the LP. If the suction line is open, LP pressure is already there. Now, when the pump is going to run, this pump, so there is going to be a pump pressure, displacement pressure, pump pressure will be there. Now, already it is having the LP pressure, so pump pressure plus the LP, because the suction pressure is there, so this LP is going to be combined. And if we are going to put the gauge to see whatever the oil pressure is there, it will show the pump pressure plus the LP both. And this is what it is known as a oil pressure, oil pressure. So whatever the oil means, lube oil. Lube oil, we are talking about the lube oil. Okay, lube oil pressure. So this lube oil pressure is going to show in the gauge. So gauge, whatever the pressure you see, it is a pump pressure plus LP. Now, we need to understand here that pump pressure, this pressure is going to be always fixed. It is not going to change. Okay, pump pressure, suppose it is running at the 4 bar. Okay, it will be always having the 4 bar. But if the LP pressure is there, LP pressure changes. It is a variable. It is going to change as I have shown you from the cut in to cut out. Like suppose I can say from 2.5 bar to suppose 6 bar. It is changing continuously. I am just taking an extreme one, second stage, third stage likewise. So it is going to change between these 2.5 bar to 6 bar. That means if I am going to get the output here in the lube oil pressure in the gauge, so it is going to show me always 6.6 bar to the 10 bar. So this is going to vary. Okay, because this is fixed, this is variable. So this is also going to vary as per the LP. So whenever you might have seen your lube oil pressure gauge always showing a higher reading, okay, than your LP pressure. Always you might have seen. Whatever the LP pressure is there, your lube oil pressure should read always higher than that. And this is the region. Okay, whatever the LP is there, that is the fixed higher. You can see 3 bar or 4 bar, it is going to read always higher than that. So what is the region? Region is this. So you have a fixed pressure. This is a fixed. This is not going to vary, but this is a variable. And that's why this is also going to read higher than the LP pressure. This is the oil, lube oil, yellow pressure is going to be always higher than, this is the gauge pressure we are talking about. So this gauge pressure is always going to be higher than this. Now, how to make a LOLP trip? Because we'll never come to know what is the pump pressure. Okay, pump pressure we are not going to come to know. So what we are doing, we are going to know the pump pressure for the LOLP trip. So pump pressure, we are going to find out, that is the gauge oil pressure what is showing in the gauge oil pressure minus LP. So this is known as a differential pressure. Okay, this is the differential pressure of the gauge oil pressure and LP. So now, if I want to find out the pump pressure, I know that it is going to be 4 bar. Gauge oil pressure here, suppose I take, it is a 6.5 bar here to 10 bar minus this 2.5 bar to 6 bar. So always this is because this is fixed or constant, it is always going to be 4. Now what I do that I set a limit here that if it is going to be less than 1 bar, there should be a LOLP trip. LOLP trip. It should happen. Okay, if it is going to be less than 1 bar, LOLP trip should happen. This setting I am going to do, this is the setting. Okay. Now, to find out this, if it is going to be less than 1 bar, what I do, I am going to use a sensor, and that is known as a differential pressure switch. Differential pressure switch. Okay, this is the switch I am going to use. Differential pressure switch. How it looks like, just see. I am going to give you the picture so you understand this one, how it looks like. They looks like this. Okay, you can see here. Now here you can see the LP that is coming this side. This is the LP that is coming. Okay, whereas this side the oil pressure that is given to this side. Now, if the difference that is going to read between this is less than 1 bar, these contacts are going to operate. There is a delay setting is also there. You can see sometimes you have a delay setting and there is a timer reset button that is also there. So this is a reset button. This is a timer reset button. Okay, and there will be the delay that will be there in this one. So this is how it is going to work. So this is a pressure that is going to come. We are going to set this one. So setting we are going to do from here. This is the setting lever. You can see pressure setting this. So from here we are going to set like 1 bar. Okay, that is the difference. We are setting a difference here. So 1 bar difference if I am going to set, that means if the difference is going to be 1 bar, it will operate and it is going to trip the compressor. So this is the oil protection switch. Okay, this is the oil protection switch. Hope it is clear. Any doubt in this? Okay. So this is a differential oil pressure switch or oil protection switch. This is how it works. Okay. Now, this is the protection we have here. That is the differential oil pressure switch. Now there are the another protection that is also there. And this one is here at the discharge point. So discharge point, we are going to have a discharge pressure switch or HP switch. Discharge pressure switch, generally it is going to work at the 24 bar. It is generally discharge pressure switch, yeah, 24 bar, and it is also a manual reset. So if it is going to be 24 bar, it depends upon model to model what it is there. Okay, as per that. So if the discharge pressure that is going to go beyond 24 bar, it will trip the compressor. So this is the safety of the compressor. Differential oil pressure switch, this is a safety. Discharge pressure switch, this is also a safety. There are another safeties are there in that we are going to have some thermostat. If there is a bigger plant, then we are going to have this thermostat. That is also a safety. If there is a small plant, then generally this thermostat is not there. In this case, we are going to have some different type of protection that is known as a overheat protection switch. Remember this one? This is the protection switch or heat protection switch. If there is a big plant, so I'll be writing here for big plants, for bigger plants. Generally, we are going to have a thermostat switch. Bigger plant is generally going to have a motor and compressor, and this motor is basically, this compressor is belt driven. Okay, in this case, generally you are going to have thermostat switch. Now this thermostat is also known as a dual thermostat switch. Why it is known as a dual thermostat? Because it is going to measure the discharge vapor temperature, and second, it is also going to check the lube oil LO temperature. So it is going to measure that. Okay. Now, when the temperature that is going to be more than 80 for the low wall, this one, if it is going to be more than 80 degrees centigrade, this is going to operate, and this is going to be more than 120 degrees centigrade. So this is the generally setting for the vapor, discharge vapor temperature, and this lube oil, if it is going to be more than 80, because it is going to lose the property over the 80 degrees centigrade. So this is how this 12 thermostat switch that is going to protect the compressor. Now, if there is a for a small plant, if there is a small plant, like small ships are there, we are having a small plant. In this case, the compressor and motor are together, and this is known as a semi hermetically sealed compressor. Semi-hermetically sealed or hermetically sealed compressor. So if you are going to have like this compressor, in this case, the motor is protected. So the motor winding is being cooled by the refrigerant. Remember this one, refrigerant. So this refrigerant is going to pass through the motor winding, and it is being cooled by this refrigerant. Okay, that means if the refrigerant is not there or it is not coming to cool the motor winding, in that case the temperature is going to rise. So winding is embedded with thermistor, and this all thermistors are known as a PTC thermistor. PTC thermistor. What is this PTC thermistor? That is the positive temperature coefficient thermistor. So it will be embedded, this winding is embedded with PTC. So these settings are there for this one, and these settings are generally, it is going to trip off or cut out is there at 130 degrees centigrade, whereas cut in is there at the 108 degrees centigrade, cut out is 130 centigrade. Means it is, if the temperature is going to be beyond 130 degrees centigrade, it will cut out. But when the temperature is lower to the 108 degrees centigrade, again it is going to cut it. Okay, below this, of course, it is going to be always on, always it is going to be cutting. Okay, so this is how it is being protected. So this protection is known as a overheating protection. What it is known as? Overheating protection. Okay, this is known as a overheating protection. And here we are going to place the thermostat. How this thermostat looks like, I'll just put it here so you can see the picture of that. So this is the KP, generally the KP, that is the name of the dual thermostat. You can see KP98. Okay, that is being used. So you can see here it is placed in the discharge line and plus the crankcase where the lube oil is there. So this is the sensor here. And this is the sensor. So this sensor, one sensor is placed in the discharge line, second is placed at the crankcase where the oil is there. So it is going to monitor the temperature, and here it is going to monitor the discharge line. Motors, generally in the winding itself, there is going to be the overheat protection. So these are the protections are there of the compressor motor. Okay, so this is the compressor motor. Now, thereafter we are going to have the oil separator. Oil separator, because when we are going to compress the vapor, the oil, refrigerant oil, that is also going to be carried with the vapor, and that has to be separated. If we are not going to separate, then there it is going to give a trouble that wherever we are going to have the valve like this, you can see solenoid valves are there. Okay, then liquid valves are there. Many places thermostatic expansion valve, this is also a valve. It is going to give a trouble by because this is going to have this oil. So this oil is going to, suppose if there is a moisture, if there is a moisture in the oil, means if there is a moisture, means air is inside, if it is the plant, moisture also is going to come. And if the moisture and oil both are going to mix, then it is going to emulsify. Emulsify means it is going to become solid like a wax. Okay, and it is going to give a erratic function of the valves. So this is a cause of concern, erratic function of solenoid valve or thermostatic expansion valve. That is the one problem. Second problem, if the oil is carried and it comes to the evaporator, here in the evaporator, okay, that oil, if it is coming to the evaporator, now if it is coming to the evaporator, because here it is a low pressure, it is going to generally settle at the evaporator. And if it is going to settle this one, your cooling capacity is going to reduce. Cooling capacity reduces. Okay, so this is if it is going to reduce again because the dia is going to be less, it is going to decrease. Inside the oil is there in the evaporator. So your dia is going to just get choked by this oil. I'm not talking about moisture, I'm talking only about the oil, and it comes and settle at the evaporator, then cooling capacity is going to reduce. Okay. So that's why we required this oil separator, which is going to separate. There is a needle valve. When it is going to fill up, this valve will operate and oil is going to return back to the compressor. Okay, it is going to return back to the compressor. You can take a break of 5 minutes, then again we'll resume the class. Okay. Now next, from here, the vapor. This vapor is going to be high temperature and high pressure. Already we have discussed about this. So this is the high pressure, high temperature. From here again, it is going to come to the condenser. Now condenser, if it is the bigger plant, we are going to have condenser plus receiver. If it is going to be a smaller plant, then condenser and receiver both are same. Now the condenser, we have the tube. In the tube, we are going to have the cooling water. So there is the cooling water that is going to come to this, and it will condense. The condensation will take place of the vapor. So there is a gauge glass. So this is known as a liquid gauge glass. So here we are going to have the label, and there is going to be a marking in this one. Gauge glass, we are going to have a marking. And it is always mentioned here, this is the minimum and this is the max. That means whatever the liquid we are going to have after the condensation, it should be between this. When the compressor is not running, when the compressor is not running, okay, or when we have closed this liquid valve, outlet valve, if we are going to close this one and we are going to collect the refrigerant, in that case, it should not go more than the maximum level. If it is going more than the maximum level, more than max level, it is known as a overcharge plant. There is a complication if there is a plant that is going to be overcharged. Remember, there is a complication. I will tell you what will be the complication. Okay, when we do the troubleshooting, I will be telling you. There is going to be the complication of when the plant is overcharged. If it is less than that, in this case, less than minimum level, this is known as plant is undercharged. Undercharged. And if the plant is undercharged, again it is going to have the complications. This both will be talking about overcharged plant and undercharged plant. What will be the complication? So always our level, when we are going to do the pump down, cross means pump down. When we are going to do, our level should always be between the max and minimum. Always. It should not be more than this. It should not be less than the minimum level. Remember this one, many people are having in the habit that if the plant is charged, sufficient charge is there, still they are charging because cooling is not there. Okay. Of course, there is a guidance from the chief engineer because ETO is not going to work by himself. Chief engineer, they are saying just charge the plant. Charging the plant is not an option. Remember this one. There may be some other problem. We'll see in the troubleshooting. I'll be giving you some do's and don'ts, okay? And the troubleshooting. What will be the troubleshooting? If this is the symptoms, if that is the symptoms. I will be telling you. So let's first concentrate in this one, then we'll go for this troubleshooting and all. So always it should be at the level. If it is if you are going to pump down, And if your level is between the max and minimum, do not charge the plant. Okay, whoever says that do not charge because you have a sufficient refrigerant in your system. Okay, now there is one more safety that is going to come, and that safety is known as a pressure relief valve. If you see here, this is a pressure relief valve. Pressure means we are talking about the refrigerant pressure. Refrigerant pressure. So refrigerant pressure, that if it is going to be beyond certain level, okay, this is going to be operated. So it is going to operate if it is going to be more than that. Of course, it is going to be more than the 24 bar. The setting will be, of course, it is going to be much more than this one. So if it is going to be more than that, your this relief valve is going to operate and it is going to release all the refrigerant to the atmosphere. So all your vapor is now in the atmosphere. It has gone to the atmosphere. Finished. Nothing will be there in the condenser. Okay. Sometimes we are going to see that our discharge pressure is high. If the discharge pressure is high, there is one of the possibility. Okay, let me write down one troubleshooting I am telling you here because it is important to tell you. If discharge pressure is high, if discharge pressure is high. Now, if it is going to be high, there will be many regions, but this is the most common regions are there that your cooling water flow is less or temperature is high. Cooling water which is coming to cool down, either the temperature of that one is high or the flow is less. In that case, your discharge pressure is going to increase. Now next is if air is in the system. System means AC or refrigeration system. If air is there, then also your discharge pressure that is going to show more than what it's supposed to be. Now, how to check this one? There is always a chart that is given to see this one. That chart that is going to tell you that what's supposed to be, it will be given in the manual basically. You need to see that one, that what should be the discharge pressure at that particular temperature. So suppose the cooling water temperature, how much the temperature is there of the cooling water. Generally, we have the thermostat that is put in the cooling water line. So you will come to know what is the temperature and what should be the discharge pressure. It is given, this chart is always given pressure in the manual. You need to look for this one. Now suppose if your cooling water temperature is 38 degrees centigrade, your discharge pressure, okay, this also depends upon whatever the refrigerant you are using, 134 or 404, whatever you are using as per that. It is going to show you 90, is supposed to show near the 19 bar, remember. If temperature is this, if it is going to be 32 degrees centigrade, in this case, it's supposed to show 17 bar. It is going to show you 17 bar. Okay. If it is going to be 27 degrees centigrade, it's supposed to show 15 bar near to that. If it is going to be 24, it's supposed to show 14. Okay. And always we should keep our this discharge pressure more than 13 bar. It's supposed to be in any condition. Discharge pressure has to be more than 13 bar. Okay, if it is going less than this, means there is some problem. Okay, it is some problem. So it's supposed to be always more than 13 bar. And it's supposed to be less than 24 bar. So it's supposed to be between this 13 bar, more than 13 bar, and less than 24 bar. So this is about the okay our discharge pressure. So we will just write here the discharge pressure dp. Okay, should be always less than 13 bar, more than 13 bar, and it should be less than 24 bar. This is the maximum it can go 24 bar, but it's supposed to be. Now you know this you can find in the manual. What is the cooling water temperature and what will be the discharge pressure. Now it is we are having the LT cooling. So LT cooling, generally this problem will not come, but if there is a seawater cooling, then seawater temperature changes according to region. So your discharge pressure is also going to change. Now in this condition, you will come to know that what is the problem, why the discharge pressure is showing more. If it is showing more discharge pressure, this two could be the reason. One is cooling water flow is less or temperature is high. Second, air may be there in the system. These two possibilities are there. So with this chart, you will come to know. If the cooling water flow is normal, temperature is same what it is showing, still the discharge pressure is showing high, that means you will come to know, you can conclude that there is a air in the system. Okay, air is there in the system. You can find out. So this is how the systematically you should do the troubleshooting, not blindly. Now, in that case, what you need to do, you need to purge the air. Here it is written gas purging. Gas purging means basically we are going to purge out the air through this wall. So we are going to open this one just for 1 to 2 seconds. It is more than sufficient to purge the air. Now how to purge this air? Purging this air, whatever it is there, it is very systematically you need to do. You need to pump down first. First is the pump down. So during the pumping down, all the refrigerant is collected in condenser. Now when it is collected in the condenser, cooling water should run at least for running at least for 3 to 4 hours. Remember, if it is not possible, at least minimum 1 to 2 hours is supposed to be there. So I will just write more than 2 hours. It is very much need because all the refrigerant should condense and change into the liquid. Now what will be there? Air. Air is non-condensable gas. It is cannot be condensed. So air is non-condensable gas. So if it is not condensable gas, it cannot condense. So only the air is going to remain on the top of the condenser, top of the condenser. So it is going to be on the condenser, on the top of the condenser. Now if it is going to be on the top of the condenser, And already the condenser is having the pressure because it is going to have a very high pressure, 19 bar, 17 bar is very high pressure. Okay, so if you are going to open 1.2 seconds, all the air with the pressure, it will be out. You may lose some amount of refrigerant because it is very high pressure and very quickly you have to do this gas purging, this air purging this. Very quickly you need to do this. This is very, very important. Okay, do not open for more time. Otherwise, you are going to lose your refrigerant. You need to watch for your discharge pressure also when you are purging out the air. Okay, so this is the purging out. Now here also we are having air purging valve, drain valve, here also the drain valve. These all are there for the cooling water line. Cooling water line. So when we are going to open for the condenser cleaning, the tube cleaning, that time we need to first drain out. When we need to close this, we need to drain the water. Water will be out, then we can clean again, box up back. After the boxing up, generally we open the inlet valve. This valve is opened first. This is remain closed. Okay, and we are going to open the drain valve. So all the air will be out through this. Once it is draining, we need to close this drain valve. Then the air, whatever the air is there, that is going to purge out. When the water is going to come out from this air purging, we open this one. Okay, this is how your air is already purged. So you need to do in this way. Okay. So first you need to open the inlet. Then thereafter, when the water is draining from the drain valve, close both. Then when the water is coming out of the air purging, one air purging will be here also. Okay, when it is going to come out from this air purging valve, then you open the outlet valve of the cooling water. This is how we need to do this. Okay, so if your all the air is going to purge out. Now, next from here, the liquid. Now the liquid, again the liquid is going to be the same. It is going to be this liquid is high pressure, high temperature that is going to come to the filter dryer and side glass, and it is going to come to the solenoid valve. Let's see about the silica gel. Silica gel is not there nowadays. Nowadays it is not being used. Olden days it was being used, but nowadays it is a different type of materials are there, and that is not as known as a desiccant. Desiccant, I will write it. Okay, so these are there along with a side glass. So this is the modern filter dryer. Just I will put it here. That is being used. You can see this is the module. You need to change nowadays. You cannot replace anything. You need to change this full module itself. Okay, full this module you need to change. So this is the solid desiccant. That is what I was talking about. This is the desiccant. So you need to change this module itself. Now here, this is going to absorb. This is going to absorb. Remember. Plus, it is not only going to absorb, it also filters. Filters the any small metal particles or any particle, not only metal particle, small particle. Okay, or we'll say any foreign materials are there. Materials. foreign materials like dust, metals, likewise. If any debris are there like this, dust or metals or anything that is going to be absorbed by this one. Okay, so there is a screen, then the metals and desiccant. Now the direction of the liquid flowing, it is from this side to this side. Okay. So this is a modern time. Nowadays we use this filters, dryer, and directly you need to change this one. Then there is a side glass. Now if you see the side glass, this side glass look like this. Okay, this is the side glass. Now this side glass is going to tell you two things. It is going to tell you two things. What is the meaning of here? The color coding is there, you can see. So it says two things, side glass. It says that either there is a moisture, if there is a moisture, in the system. If there is going to be moisture in the system, that means your filter dryer is exhausted. Exhausted means it is not working now. Okay, already it is finished. So you need to change. So moisture is there. Now if the moisture is there, the color will change from green to yellow. I hope it is very clearly it is given. It is dry here. You can see it is a green and it is written wet. Wet means it is having the moisture. Here also you can see it is written wet and it is a dry. If it is a dry, it is green, and if it is going to be wet, it will change to the yellow, from green to yellow. Okay. Second, it is the indication. Second indication, it is going to give if there is a froth. Froth means bubbles. So if there is a froth or bubble, that is here. Here, if there is a bubble, if there is a bubbles in this one, just I will make with some different color here. If you are going to see the bubbles here like this, okay, or there is a froth, like soap water froth, you know it. So like this, if the froth is there, okay, that means it indicates that there is a less flow of refrigerant or liquid, because here the liquid is going to pass, less flow of liquid. Now, if the less flow of liquid is there may be many regions. Okay, that is not only one region. Why the less flow is there? There are the many regions. If we see here, this diagram here again coming back. So if you are going to get here the bubbles or the froth, here there could be many regions. One region that your filter dryer is chopped. Okay, filter dryer is chopped. Already it is chopped. So if it is going to be choked, then also there is going to be problem. This wall is not opened fully or not opening fully. Liquid outlet valve. It is a manual valve, but it can have trouble, then also you are going to have the problem. Or lastly, we can say this is very less chances are there of this, any problem of that. But there are the chances that plant is under charge. Plant is under charge. Now, how you will come to know that plant is under charge? Okay, if the plant is under charge, you have to pump down, you have to see the label. If the label is okay, that means your silica gel is giving you the trouble. You need to, this filter dryer is going to give you the trouble. You need to change this filter dryer. Okay. But what people are doing, they are just charging the plant again and again. Do not charge the plant. You need to go very systematically to understand this system. So if the bubbles are there, that means the passing of the refrigerant is going to be less. It is less here. Okay. Now next come to the solenoid valve. Now what is this solenoid valve is doing? Okay. Okay, this solenoid valve. Now this solenoid valve which is there here, this solenoid valve, you understand, this is the solenoid valve. This is going to be operated by the temperature setting thermostat. This temperature setting thermostat is there in the AHU, air handling unit. You might have seen it is located here. Generally, it is set at the 20 degrees centigrade or 22 degrees centigrade. Okay, we'll take 20 degrees centigrade. Now, if it is 20 degrees centigrade, there is also a plus and minus in this one. So there is a difference in this. That is the 2 degrees centigrade. This difference is by default. We can't change this one. It is a factory setting. Already it comes, this thermostat. There is a sensor. This sensor you can see, this valve that is fitted. There is a temperature sensing bulb. This bulb is going to send the temperature, current temperature of the air, inlet air, incoming air. Okay. Now, if the incoming air temperature is going to be the 22 degrees centigrade, then it will switch on. It will switch on the solenoid valve, or this is also known as a magnetic valve, MV. This solenoid valve is also other name is the magnetic valve. So this magnetic valve is going to be on. Now incoming air temperature, if it is going to be the 18 degrees centigrade, because plus minus 2 degree means 4 degree range is fine. This magnetic valve will be off. It is going to be off. So this is how the thermostat controls this solenoid valve. So it is going to be on and off as per the temperature setting in the thermostat. Now, when the magnetic valve is on, that time your LP pressure is going to increase. Remember, LP pressure will rise. If the LP pressure is going to rise, your compressor is going to be on, and when it is rising and it's reaching to the 4.5 bar, 4.5 bar, the compressor is going to be on. When it is reaching to the 18 degrees centigrade, in this case, what will happen? In this case, it will be magnetic valve is going to be off. That means LP pressure will fall. If LP is fall, low pressure will fall. And if it is going to be 2.5 bar, the compressor is going to be off. This is how this temperature setting is controlling the compressor on and off. This is how the compressor is being controlled by the LP or suction pressure. Is it okay to everyone? Understood up to here? Okay. Now, next is TEV. So TEV, that is a thermo expansion valve. Now this thermo expansion valve is also having a sensing valve here. You can see here. This is a sensing valve. Now this sensing valve is placed in such a way. This sensing valve is placed in such a way that evaporator output or outlet, evaporator outlet is already having the saturated vapor. Saturated vapor. Now, this saturated vapor. So this saturated vapor, so this TV where it is put, this TV is put that it is going to give a 5-degree superheat. 5-degree superheat. Now what is this superheat? Remember this superheat? Okay, I will tell you what is the superheat. Now again come back to this diagram. When we are going to heat up the saturated vapor, means if you are going to heat up more the saturated vapor, when we are going to heat up more the saturated vapor, that becomes the superheat vapor. That becomes a superheat vapor. Means if I am going to make more heating and it is reaching up to here, this point. Okay, so or I'll just take some of this one up to here like this. Okay, so this point means after this line, saturated line, if the vapor is heated more, this is known as a superheating. This is known as a superheating. Similarly, if I am going to cool down, below the saturated line, this is liquid line. If I am going to cool down further, this one here, okay, like this. This is the diagram that is going to flow. So if it is cooled down more, this is known as a subcooled liquid. Subcooled liquid. And this is known as a superheated vapor. They are known as a superheated vapor. What is the advantage I am going to have by this superheated vapor? If the superheated vapor is there, superheated vapor, that is the correct word. Superheated vapor, if it is there, my efficiency of the cooling increases. Same way, if I am going to have the subcooled liquid, my efficiency is going to increase. That is the one. Second is, if I am going to have the superheated vapor, there is no chance. There will be no chance that liquid is going to enter to the compressor. So this is the advantage I am going to have due to the superheated vapor. And this superheated vapor here is set. So this is the 5 degrees superheat vapor that is set in the TV. TV means this sensing valve of the TV that is placed in such a way that it is going to provide a 5 degrees superheat. Always 5 degrees superheat. This is the factory setup, and this is always going to provide 5 degrees superheat. Means your TV will allow the liquid to pass through this TV in such a way that here always the 5 degree superheat is maintained. 5 degree superheat is maintained. And that is how it will be throttling as per the outlet of the evaporator. So as per that, it is going to throttle this TV and it is going to maintain a 5 degree superheat. How this TV looks alike, just I am going to give you a picture of that one. Okay, this is the TV thermostatic expansion valve. If you see here the dia which is coming this side, as I have told you, the dia, so this side the dia you can see, suppose it is a D, and this side the dia you can see, it is going to be the 2D. This is a needle valve, and this is the bulb with the capillary tube. Here there is a diaphragm, this is the spring, and here what we are going to set, it is set always 5 degree superheat. You can see there is a strainer here, this is the orifice, and when it is going to open, this is going to be this side, it is the LP, and this side where the entering, this is going to be the HP. So this is the high pressure, this is going to be low pressure. The refrigerant, this bulb is going to have the refrigerant, same refrigerant of system, same refrigerant of system. If the system is going to be R134A, this is also, this bulb is also going to have the same refrigerant. Okay. Any doubt to anyone up to here?
So, I missed the entropy and enthalpy. Can you please explain?
What is that?
Entropy and enthalpy, sir.
No, I will repeat tomorrow because now I am also tired. Okay.
It's okay, sir.
Yeah, tomorrow I will tell you, just remind me. Okay. Okay then. Thank you. Thank you very much. And good night to everyone.
Thank you, sir.
Thank you, sir.